Inside this episode, raising the bar for most UAVs in coordinated flight.
We talk a lot about B-2 bombers and long-range missiles and advanced weapons, but really the secret to our department is our people.
Senior leadership shares insight for our changing world. And interns flock to NPS to aid vital science and technology research. Once again, the Naval Postgraduate School takes the lead on unmanned aerial vehicles, or UAVs. Our Advanced Robotic Systems Engineering Laboratory, or ARSENL, successfully flies 30 UAVs in a coordinated swarm. This breaks the earlier record of 20 UAVs set by ARSENL in May of this year, and sets the bar for others looking to do the same. From McMillan Airfield at Camp Roberts, MC3 Brian Abel has the full story.
It's on the battery anyway. Yeah.
Event 23, Mission 23, UAV 40.
We are here at Camp Roberts, and we are here to do our live fly field experimentation for swarm UAV testing. Swarming is turning out to be one of those capabilities that are both on the defensive and offensive side of interest to the Navy and the Marine Corps. And one of the things that we're doing here is to help push those boundaries and understanding what state-of-the-art is in terms of swarm technologies. We've been able to significantly enhance how we've conducted our live fly field experiments, ranging from just as few as 6 to 9 aircraft. Now we're all the way up to 20, and we're here aiming for 30 aircraft if we can, but even anything breaking our previous record of 20 is already gold for us. Our target number is to get to 50 UAVs in live fly experimentation. There's some operational reasons why that number is of particular interest to us. But on top of that, I think it far surpasses anything that we've ever seen before, and we're interested in kind of carving out that next frontier for swarm UAVs.
What I have in store for us is as follows.
NPS students have been involved all the way from the concept generation side, looking at tools from modeling and simulation to be able to understand some of the nuances of swarm tactics, swarm logistics, and being able to understand even the technologies that one would try to bring together for this, all the way to the field experimentation side, where we're interested in building things and testing them out here on the field. One of those things is, for example, a rapid UAV launcher technology. Other things have been understanding how to involve swarm search algorithms and being able to implement those. And so we've had our students involved on the full spectrum of this entire project.
I was a student at NPS. I just graduated, master's in systems engineering. So now I'm just assigned to Professor Chung's ARSENL lab to help out over the summer. Flying a swarm UAVs, there's a ton of problems that have to be solved. Logistically, one of those is launching the aircraft. And the aircraft we use is a Zephyr 2. It's electrically powered and has about a 45-minute endurance. So when you're trying to get 50 aircraft airborne at the same time, you're running against the clock on launch cycle time in order to have any kind of mission endurance. So what they previously used was a bungee launcher, and it took about 1.5 minutes to 2 minutes to reset each flight. If you do the math on that, it takes 75 minutes just to launch the swarm. At that point, the batteries are dying. So we designed this, and it takes the cycle time down to 15 seconds so that they can get the whole swarm airborne in 15 minutes. Gives them about a 30-minute combat endurance. Instead of having one very expensive asset, which we know in wartime can get lost, we lose assets, aircraft goes down and it's a $55 million, possibly more per copy. With the swarms, you have $500, $1,000 machines, and you can use 100 of them and accomplish the same mission as a single, very expensive asset. So it diversifies. And also, swarms maintain efficacy just based off of numbers. So there's no checkmate per se. You can't take out one individual aircraft and see any significant degradation in the operations of the swarm. Whereas if you're flying a single unit like a Global Hawk or something along those lines, you lose your asset, you can have a significant curtailment in your capability. Where we would like to eventually get with artificial intelligence and swarming is to let the swarms determine what the correct course of action should be. And that's actually one of the long-term goals here at ARSENL. They want to do a 50v50 air war, where instead of an operator actually telling each aircraft what to do, they're making their decisions collectively through emergent behavior in a way that lets them dogfight on their own. and we're not even in the loop. So essentially the human's been removed, the swarm's making a decision, and it's doing it inexpensively with a lot of cheap items that collectively build a higher intelligence. This is a capability that we're starting to acquire. What we can do with it, virtually limitless.
3, 2, 1.
I think one of the interesting things that we've been able to do with this project has been to help recalibrate what the public opinion is, what public's perception and opinion is on both robotics and unmanned systems as well as swarming. I think one of the key challenges here, of course, is to understand what the different mission sets might be for swarm technologies, and those might include everything from being able to survey large swaths of agricultural fields so that farmers can do better optimization and utilization of, let's say, water, which is an increasingly scarce resource. Another application would be something for the Coast Guard or combat SAR, search and rescue, where you're able to deploy larger numbers of assets to go conduct a search and rescue mission. As we start thinking about these types of technologies, where aircraft, in our case, are able to communicate with one another, they're able to coordinate their searches, you're able to have fewer humans in the operator seat so that they're able to do the tasks that we need to get done without operator overload or sprawling manpower requirements. We're really helping trying to push those boundaries on both the military but also the civilian side. One of the exciting things about this project is being able to do it with such a small but talented team of people, ranging from our collaborators from across different departments and organizations. We have ONR, NRL, S&T reserve officers that have been participating, and they've been essential for our ground operations. We have our interns ranging from juniors in high school all the way to graduating seniors in college that have been contributing to this project immensely. So we're able to only do this with the support of a number of really key, talented, hand-selected, if you will, individuals that are participating on this team, and none of this could be happening without their kind of ingenuity, their initiative, and their innovations. And so it's just been an amazing opportunity to work with this group of people. Quantity is a quality all on its own. We have an opportunity to push the boundaries of both technologies and capabilities. We want to understand what the limits are and what the benefits are of those types of capabilities.
When we return, senior leadership share their insight.
We need a new generation of analytical thinkers that foster and inculcate to everyone around them a culture of innovation, experimentation, and adaptation.
The Consortium for Robotics and Unmanned Systems Education and Research, or simply CRUISER, promotes the education of U.S. naval officers in the design, development, and employment of robotic, autonomous, and remotely controlled systems. We do this through various fora that bring together defense-related advanced education, research, and commercial innovations. Serving as an incubator, CRUISER seeds and advances the exploration of innovative and fresh ideas that support the efficient attainment of mission objectives. Faculty, researchers, and students work together in the classroom, in the lab, and in the field to develop innovative ways of combining old, current, and emerging technologies to extend the commander's reach in the battlefield. Field experimentation gives us the opportunity to test the viability of the technical ideas. Workshops and panel discussions offer the chance to explore the boundaries of ethical, legal, and policy issues associated with these concepts. Officer education in sciences, technology, and operations is essential as we move forward into a quickly changing world. CRUISER creates a unity of effort in the massing of creative and innovative intellectual firepower. Be a part of the solution. Be a part of CRUISER.
Standing outside King Hall here at NPS, where students and service members hear from senior leadership and defense experts on various topics, such as retired U.S. Army General Stanley McChrystal, who recently spoke about his 34 years as a military officer and his efforts to quell turmoil in the Middle East. Our very own Professor John Aquila, Defense Analysis Chair, served as the moderator, getting McChrystal to share his insight on how improving military networks and communication increased efficiency and quantity of operations.
When I took over JSOC in 2003, we had this daily VTC with about 50 people in it, 25 at my rear headquarters at Bragg and 25 forward. By 2005 and 6, we had the same VTC was now 90 minutes long every day, and it had 7,500 people in it. It's like going to the huddle with a quarterback. The whole command for 90 minutes talks about what's happening, what happened last night, what's happening right now, what are we going to do, what do we need to do. Everybody walked out of there understanding they didn't need more instruction on what to do. They knew what we're trying to do, and they just execute. And then you come back because that. I also, when I first took command, our plan was for me to approve every mission. And we were doing 4 a month, 1 a week, so I could handle that. By the summer 2006, we were doing 300 a month in Iraq alone, and more elsewhere. There was no way. And nor should I have tried. I wasn't smart enough to be value added on those. And so what we did was create an environment where they do it. And my role changed to really being an orchestrator of the conversation.
NPS also welcomed Deputy Secretary of Defense Robert Work.
There's absolutely nothing more important to the future of our security establishment and the security of our great nation than educating, developing, and preparing our future leaders.
Work took part in our spring 2015 graduation, giving the commencement address. Work was also recognized as a distinguished alumnus of the Naval Postgraduate School. The Deputy Secretary took time out of his busy day to talk with us and share his insight. Thank you for joining us today. Your visit comes on the heel of an acquisition conference here at NPS. Considering your background in acquisition, could you provide some insight in graduate-level education and its contribution to the DoD?
Well, the secret weapon of the Department of Defense is our people. We talk a lot about B-2 bombers and long-range missiles and advanced weapons, but really the secret to our department is our people. That's why Secretary Carter has launched what he calls his Force of the Future initiative, which is really focused on attracting and retaining the absolute best talent we have. And that includes not only acquisition, but all of the other things we do. Right now we're under so much scrutiny to give the best bang out of the buck. And there's no better way to do it than to send people to schools like NPS where they learn their trade and can apply it and really provide us with great capabilities at the best cost.
For more than 2 decades, the United States has been unchallenged generally as the single world great power. That is an unprecedented circumstance. That moment is coming to an end as we witness a more multipolar world where U.S. global leadership will be increasingly challenged, and perhaps no more so than in the military realm.
During your speech, you spoke at length about challenges the United States faces right now. You spoke significantly of Russia, ISIL, and the South China Sea. You also talked about the importance of technology and innovation. Can you share what the DoD is doing to maintain military superiority in those areas?
The Defense Innovation Initiative is designed to maintain our level of technological superiority. The Secretary of Defense has commissioned what he calls the Long Range Research and Development Planning Program, which is designed to tell us what leap-ahead technologies would provide us the best measure of technological superiority in the future.
There continues to be a significant interest in a third U.S. offset strategy you have been developing. Can you give us an idea of what the DoD gets out of it?
For the last 30 or 40 years, we've really relied upon advanced weapons, new operational concepts like air-land battle to give us an edge over our adversaries. Just as we see our technology slipping, our measure of overmatch against potential adversaries is also going down. So the third offset strategy looks at technologies, new operational concepts, new organizational concepts, and innovation to try to come up with different strategies which play to our strengths and exploit an enemy's potential weaknesses.
Deputy Secretary, you hold numerous academic degrees covering a swath of disciplines. Among them, a Master's of Science in Space Systems Operations from NPS. How does space configure into our current defense strategy, and what can the faculty and students at NPS do to improve this?
For the last 25 years, we have almost considered space a sanctuary. We haven't really worried about adversaries being able to go up and take out our space capabilities upon which we rely so much. The space constellation allows us as a global power to project power globally. And without those space capabilities, that capability would be at risk. So what's different about the next 25 years is that space is going to be a contested environment. We have to think of it as a contested domain. We have to think in terms of resilient architectures. We have to think in terms of backups. We have to think in terms of responsive space, control, defense, and launch. So what I would ask all the students and all the faculty really looking on it now is to turn their attention and say, are we really teaching our folks to worry about a contested space environment? And if not, let's change it and make sure that we do.
Deputy Secretary, thank you for your time.
We need a new generation of analytical thinkers that foster and inculcate to everyone around them a culture of innovation, experimentation, and adaptation. I envy every single one of you because you have a chance to make history.
After the break, science, technology, engineering, mathematics, STEM interns aid critical research for the Navy. According to the Department of Navy, a workforce healthy in science, technology, engineering, and mathematics, or STEM, is critical to meeting the Navy and Marine Corps' greatest challenges. More than 90 STEM interns from across the country flocked to NPS to aid defense research. For 8 to 10 weeks, these college and high school students took part in a wide array of fields.
We really like our interns. They bring energy, a certain amount of inspiration and vitality to the program.
Surprised and delightfully surprised at how smart, articulate, and poised they actually are.
There's a lot of data and there's a lot of information that we have to go through, but they've done an incredible job.
I'm really thrilled with the level of leadership they have.
It's really fun to see the light go on in their eyes.
Their handle on technology, their ability to very rapidly pick up on the latest and greatest in the programming areas.
They're actually programming and have a really good results for me to incorporate in my research.
They ask a lot of really good questions that make me question how we've solved the problem and look at the problem from a unique perspective.
We talked to a few mentors and interns to get their take on the program and how it benefits the Navy.
We have students who are involved in helping to change policies and procedures within the Department of the Navy. They deal with real people, they deal with people back in the Pentagon, they deal with people on campus. This is an opportunity for them to get involved and to actually make a difference.
My project is working on eliminating the PIM policy. PIM stands for Plan of Intended Movement. Right now, we're running different test cases with different parameters, and we're analyzing the data that these test cases give us. It's fuel efficient if we get rid of this policy.
This little number right here is a p-value. At the Seed Center, we specialize in doing large-scale design of simulation experiments. I've shown them some different statistical software. I've shown them different modeling platforms that they could use to go ahead and simulate an epidemic or a disaster.
I'm doing a net logo simulation of the spread of malaria over a certain amount of time. So as you can see here, the difference between the blue and the red mosquitoes is one is carrying the parasite and one is not. So by changing the ratio of carriers versus non-carriers, you get a difference in how fast the entire population becomes infected.
SSH into 13 or 14. We're in the Center for Cyber Warfare. A lot of other schools are looking at cybersecurity and how do you prevent cyber attacks. We're looking more at how do you do the defensive operations, how do you do offensive operations.
So we have one big network and then a small isolated network, and we're trying to direct traffic and manage it and make sure they are not malicious.
It's nice having multiple people work on research with you. They come in with a fresh set of eyes.
Programming is a little bit difficult at first, but once you get it, you have this sense of accomplishment. I think coding is a language that people from all over can understand and communicate through.
You could go back. So the example.
My daily job is to write and debug code. Essentially, it's a form of text mining that can be represented in word pairs and create 3D interactive visualizations using something called D3, which stands for Data-Driven Documents, and JavaScript.
Sometimes data is too complex. You want the big data, but then you want to transfer them into smart data. The visualization part is a key because you have to be able to see how those nodes are moving in an interactive way. So if we show it well and people understand, then your research is good.
You guys have been using the Regal scanner.
Yeah, we've been using the Naval predominantly, so I'm not very familiar with this whole setup.
The student interns are out in the field accurately measuring the locations of things, anywhere from trees to tables to corners and intersections, using some pretty expensive GPS equipment. We're able to measure positions accurately down to perhaps 10 centimeters. And we need that kind of accuracy when we're calibrating our airborne data.
This summer I've predominantly learned how to conduct my own surveys out in the field, along with applying the data that I've collected in the field to different softwares back here in the lab. And it's really taken me through the step-by-step process of not only collecting the data, but also being able to interpret it and analyze it independently.
CVMR identification, how they identify as the Navy, sailor.
How resilient they are as a division, but also how they are as individuals.
My field of research is with social psychology and organizational behavior, looking at issues related to how people work and work together and are led in organizations and how they work as teams, how they accomplish their jobs. We want to understand how people think, how they feel, and how they understand their world.
We're doing this resilience study, and it's with the boot camp at Great Lakes. We're basically looking at how these people handle boot camp and the stress that comes with it, and if there's possibly any interventions that may assist in that process. This research focuses on how can we make this the best possible situation for these people, regardless of the crises they may face in the future and the stress that they're experiencing. How can we make this the best for them now and in the future? And when we do that, that organization of the Navy benefits as a whole.
What's going to come in here, and then how do you turn it on and off? With the Space Systems Academic Group is to give the students an opportunity to learn about how space impacts them. So our summer interns have a real program to work on. We'll test our ground station here at the Naval Postgraduate School against a high-altitude balloon out in the Central Valley with mobile ground stations in cars with ground station software that they've written themselves.
This is the high-altitude balloon payload. Inside of this tube, we have the accelerometer, the thermistors, the radios, and an onboard computer, so Raspberry Pis in here. When we get this payload back, if we get this payload back, we extract all the data from our sensors and our other devices, and we analyze how they did in that environment.
We have a couple of military students who are working with our summer students. Their operational experience is very valuable. These students have not had these opportunities yet, and so they're able to share with them their experiences in the field and also to give them a good understanding of how important certain parts of operations are.
My work as an intern currently is the fabrication and characterization of carbon nanofibers, and basically what that entails is to fabricate the carbon nanofoam, and then from there, basically we have to learn all the ways to create the foam, and then we take it a step further and start testing it with various instruments like the Instron and the scanning electron microscope.
The project that they are participating is not only a summer project, it's a project that is ongoing, that has significance for society. We're trying to develop better materials in our case. We're trying to basically advance the knowledge, and what they are doing is an essential part of it.
They bring so much excitement and youth into the school. They're ready to take on any task. You just give them one thing and they just run with it. They take the initiative and definitely are very committed.
The country needs people well-trained in science and engineering. We need to make sure we have the workforce that we will need to address the technological problems that will be coming.
If you would like more information about Naval Postgraduate School here in Monterey, California, please visit our website at www.nps.edu. This has been Inside NPS. Thanks for watching.